Hi, our group topic is statistical testing. My name is Vinisha and I would like to discuss about the introduction purpose of statistical testing. Initially, when we discuss about the definition, it is called as a test which evaluates two mutually exclusive statements about a population to determine which statement is best supported by the sample data. It is also called as confirmatory data analysis. Next, when we discuss about the need for statistical testing, it is called as a test of significance. Like if we want to prove our data is statistically significant, and when we are sure of the fact that it is unlikely to have occurred by chance or luck, then we choose statistical testing. And the primary need is to assess the likelihood of a certain possibility from the sampling distribution. Next, I would like to discuss about the steps in statistical testing. Initially, there is a research hypothesis of which the truth is unknown. The first step is to state the relevant null and alternative hypothesis. Null hypothesis states that nothing has happened or that we were correct in our theory, which is called as alternative hypothesis. The second step is to consider the statistical assumptions being made about the sample in doing the test, then decide which test is appropriate and state the relevant test statistic. Then derive the distribution of the test statistic under the null hypothesis from the assumptions. Then we need to select a significance level alpha, which is a probability threshold below which the null hypothesis will be rejected. Uh, then the distribution of the test statistic under the null hypothesis actually partitions the possible values of the test statistic into those for which the null hypothesis is rejected and those for which it is not. For those the null hypothesis is rejected is called as the critical region and the probability of the critical region is called as alpha. Then we compute from the observations the observed value of the test statistic. Then decide either to reject the null hypothesis in favor of the alternative or not reject it. The decision rule is to reject the hypothesis if the observed value, which is the p-value, is in the critical region, or to accept or fail to reject the hypothesis otherwise. These are the steps in statistical testing.
Hi, I'm Madhvilata Bodhitula and I'll be discussing about the types of statistical tests. Based on their nature, there will be mainly four types, and based on the types of variables they are used, there are a number of tests. Firstly, coming to the correlation variables, it looks for association between the two variables and will be using the Pearson correlation between continuous variables, Spearman correlation between the ordinal variables, and chi-square for categorical variables. Here the ordinal variables are a kind of categorical variables. The categorical variables are the variables which can be divided into categories like male and female. If there are two categories, then there are the binary variables. If there are more than two, then there are the nominal variables. And if there is a relation between these variables, then they are known as the ordinal variables. Coming to the comparison of means, it looks for the difference between the means of variables. If there is any change in the outcome, we will be using the paired t-test for the relative variables and independent t-test for the independent variables. And if there are a group of variables, then we will be using the ANOVA test. We will be using the regression test to test how change in a variable predicts the change in other variable, and for single predictive variable we will be using the simple regression. For more than two predictive variables we will be using the multiple regression, and if the data doesn't meet our assumptions we will be using the non-parametric test. For the independent variables we will be using the Wilcoxon rank sum test, and for relative variables we will be using the Wilcoxon sign rank test. Let us discuss two tests in particular. Firstly, coming to the chi-square test, we will be using to test the strength of association between two categorical variables. We will be using this test by this formula, where O of I stands for the observed value and E of I stands for the expected value. We will be doing the summation of these values for every item in the data set, where I stands for the ith item. Using this formula we will be getting the chi-square value. Then coming to the paired t-test, we will be using this to test the difference between two relative variables, and it is also sometimes called as the sample t-test. There are a number of steps involved. Initially we will be finding the difference between each pair and we will be finding the mean difference of them. Then we will be calculating the standard error by using the standard deviation, which helps us to find out the t statistics using the mean difference and the standard error. Here we will be calculating this value with the t distribution table to know the p value, which will help us to draw the conclusions.
We've already seen what a chi-square test is used for and the equation to achieve the same. Now let's do the manual calculation by considering a problem which is shown here. These are my expected numbers here, So for each side, we expect a value of 100. Now let's do a actual experiment and roll the dice, and these are my observed numbers. 1 shows up 89 times, 2 shows up 95 times, and so on till 6. Now let's go ahead and do the calculations for chi-square. Deviation is calculated by ohm and SE and the values are shown below. And the deviation square, which is given by ohm and SE whole square, is 121, 25, and so on. And the deviation squared by the expected values gives us these values, and the summation of this gives us the chi-square value, and which is found out to be equal to 4.7. Now we need to know if this value is a significant value for considering alpha to be 0.05. The number of degrees of freedom is given by the -1 rule. Since we have 6 sides to the dice, we have 6 variables, so 6 minus 1 equal to 5. The degrees of freedom and the level of significance is used to find out the critical value from the chi-square distribution table, and which is found out to be 11.07. So now I want to know if I can reject or accept the null hypothesis. If the chi-square is greater than the critical value, well, we can reject the null hypothesis. But in this case, the chi-square value is found out to be 4.7, and which is significantly lesser than the critical value, which is 11.04. Therefore, we do not have enough evidence to reject the null hypothesis. We are going to learn how to perform a paired dependent t-test, and we are going to learn how to do it by hand. Before we start, let's go ahead and take a look at the sample data that we are going to use. The paired t-test is done to check if there is significant difference between the pre-test and the post-test groups. Now, the problem which we are considering is shown as follows, and the formula for t-statistics is given below. D is the difference between the post and the pre-test scores. Now, the D and the D square values are calculated, and the values are found out to be as follows. The T statistic is calculated by plugging in the values that have been calculated in the previous table, and which is found out to be this, and the T statistic value equals to -4.648. Now, the degrees of freedom, which is equal to n minus 1, is since we have 14 students, the degrees of freedom equals to 14 minus 1 is equal to 13. Degrees of freedom and the level of significance is used to find out the t critical value from the t distribution table, and that value is found out to be equal to -2.160. Now the t statistic, which is -4.648, and the t critical value is compared to check if the null hypothesis can be rejected or not. So we can see that the t statistic is greater than the t critical value, therefore we reject the null hypothesis.
Hi, this is Amresh Gangwala. I'll be presenting on how to do statistical testing using Excel. To do statistical testing, we'll be needing a small data analysis tool inside the Excel. Let me actually go in and show you how to install. Go to the file, go to Excel options and navigate to add-ins. You'll see a tool called analysis tool pack. Select that and give OK. That'll be installed in for you. And when you navigate to data tab, you'll see a button data analysis. This tool helps in doing statistical methods for your sample data. Now we'll be seeing how to perform chi-square test in Excel. Previously, one of my teammates has shown how to do it manually. I'm going to use the same sample data and show it in Excel. This is the sample data that's been done manually. Now select an empty output range here and then click the insert function here and then search for chi and then go. We'll be using chi test function as part of this statistical method. Give OK. Select the actual range, that's the observed numbers, and the expected range, that's the expected numbers, and then give OK. Here we get the value as 0.4535. This is actually not chi, and this is the probability. As our probability is greater than the assumed alpha 0.05, we don't have enough evidence to reject the null hypothesis. So we say we don't reject it, and there's not statistically there's not much of significant difference between the observed and the expected numbers. Now we'll be seeing how to do paired testing in Excel, this is the same sample data that's used in the manual calculation in Excel. Now go to data analysis, select t-test pair to sample for means, select the variable 1 range, that's your before values, and the variable 2 range, that's the previous values, and the hypothesized mean difference. Here I am giving 0. If you're sure there's mean difference that you want to hypothesize, you can enter this value and then select the output range and give OK. Yeah, here's the value that I've got from the paired testing. This shows the different values for the both before and after, that's in the variable 1 and variable 2, the mean, the observations and the variance. Here I see my t start as minus 4.64 and the t critical two tail is 2.16. I'm going with the critical two tail because my data is a directionless sample data. If you have a direction, you can go with one tail. Here my T stat is greater than the T critical two tail comparing the absolute values. So we can reject the hypothesis that there is no that the mean difference is 0. As the T stat is more than T critical, we can see that the data has a significant difference for the before and after values. So we reject the hypothesis.
Statistical testing using Markov chain for software reliability. The goal is to certify the quality of software. Software quality measures are obtained by applying the statistical evaluation mechanism on the sequences and any failure data observed during the test. In this presentation, the statistical evaluation will be shown using the Markov chains. There are two chains involved. First is the usage Markov chain. This chain models the software usage and is used as a test case generator, and we can compute the usage distribution and the test case length. The second is called the testing Markov chain. From this, we are able to compute the reliability and the mean time between failure. The usage Markov chain involves two phases, the structural phase and the statistical phase. Let us see about constructing the usage Markov chain. The first diagram is the top level view of the software usage. The control of the OS is passed to the software when it is invocated. The control is passed as the usage of the software is continued and returned back after termination of the software. It is explained using this figure. Let us see the statistical phase. Based upon the test usage and frequency, the transitional probabilities are assigned, and it is done in three different ways. First is uninformed approach, second is the informed approach, and third is the intended approach. The computations on usage Markov chain. The stationary distribution is denoted by pi. The vector is computed by simultaneously solving the system of equations given below. The resulting pi is the valid probability vector with an entry for each state of the usage chain. For a chain with n states, we have the following formula. The number of states necessary until one can expect to generate state I is computed by the following two equations. The second phase in Markov chain is the constructing of the testing Markov chain. Initially, the testing Markov chain has the same state and arcs as the usage chain, with each arc labeled with a frequency count of 0. The counts are updated as a sequence is generated from the usage chain and executed as a test case. That is, for each pair of state in the test case, the corresponding arc in the testing chain gets its count incremented by 1. And whenever a test case fails, it is denoted by F and the software terminates. The computations on testing Markov chain. The divergence of testing Markov chain is calculated by the formula D, is given as here, where pi is the stationary distribution of the usage chain, Pij is the transitional property of usage chain, where p cap has the corresponding transitional properties of the testing chain. The two measures of standard software quality can be thus computed by reliability and mean time between failure. The reliability can be computed by the formula given by Rik, and the mean time between failure can be computed with the following formula, where V is renormalized stationary values for the failure states and M is the mean time for absorption of state J. These two Markov chain can hence be used as a stochastic model to determine the quality of software.
Hi, my name is Gopika Pai and I'll be speaking on two topics today, applications of statistical testing and how to choose a statistical test. Statistical test is used in several fields, which requires collection, analysis, and interpretation of data. Some fields where statistical testing is extensively used are astronomy, as astrostatistics is a discipline that applies statistical testing for analyzing the astronomical data. biology, where biostatistics is used to analyze the observation and biological phenomena. Business, as business analytics, where it's used to develop new insights and understanding of business performance and opportunities. And in the area of computer science, we use statistical data extensively in machine learning and artificial intelligence. So when it comes to choosing which statistical test to use, there are three important things to check before choosing a statistical test. Data. Check if the data is nominal or interval ratio. So, nominal data is divided into categorical, qualitative, or non-parametric. Example of each type is categorical, where a set of colors can be divided into their types; qualitative, where some chocolate bars can be divided if into defective or not; non-parametric, you can choose into your preferred food, whether it's non-veg, veg, or vegan. The tests that involve nominal data are test for proportion, test for a mean, and difference of two means, pair. Interval ratio. Interval ratio is more of a quantitative data. Examples of the quantitative data are temperature or stock market. Interval ratio data is expressed into mean. Tests involved in interval ratio data are mean test, regression analysis, and difference of mean. Ordinal data can be classified into nominal or interval ratio. Samples, where we can compare one sample with relevant statistics that could be mean of the items against the hypothesized value quality in the percentage form. Or we can compare two samples with each other on the basis of height or weight or etc. Or in the third case scenario, where we can measure the same sample on the basis of weight, color, and quality. If there is just one sample, we compare the proportion or the mean against the given value. When it means to compare two samples, then we take the difference of proportion and difference of two means. Purpose could be testing against hypothesized value. Test for proportion, mean, and difference between the two means. It can also for the reason of comparing two statistics, or to check the relationship between the two variables, where we use chi-square testing or regression analysis.